There is a product recall for ideal voltage and voltage continuity testers. The affected model numbers are 61.65, 61.66, 61.67, 61.76, 61.79, and 61.80. The tester has a yellow body with ideal and the model number printed on the front. It uses black and red test probes. The recalled units were manufactured between November 1999 and May 2002. The hazard is that the testers may provide incorrect voltage readings, which poses a risk of electrical shock or fire. The remedy is to contact Ideal to receive a free replacement tester. Ideal's toll-free number is 877.557 8598. They are available from 7 a.m. to 5 p.m. Central Time, Monday through Friday. You can also access Ideal's website. It is important to verify if your voltage tester is included in this recall. Incorrect voltage readings can lead to dangerous situations when working with electrical circuits. Always double-check readings with a known good meter before working on any electrical equipment. Electrical safety is paramount, and using faulty test equipment increases the risk of accidents. The potential for electrical shock or fire necessitates immediate action if you own one of the recalled testers. Replace the faulty tester with a new one to ensure accurate voltage readings and prevent potential hazards. Regularly inspect all electrical tester equipment for damage or wear. Damaged or worn equipment can also produce inaccurate readings or fail to function properly. Keep test equipment clean and dry to maintain proper functionality. Moisture and contaminants can interfere with the accuracy of readings. Always follow the manufacturer's instructions for proper use and maintenance of electrical testing equipment. Using the equipment outside of its intended parameters can lead to inaccurate readings or damage to the equipment. Be aware of the limitations of your testing equipment. Some testers may not be suitable for certain types of circuits or voltage ranges. Use appropriate personal protective equipment, such as insulated gloves and eye protection, when working with electrical circuits. Always energize circuits before working on them whenever possible. Lockout-tagout procedures should be followed to prevent accidental re-energization of the circuit. If you are not qualified to work on electrical circuits, seek the assistance of a qualified electrician. Working with electricity can be dangerous, and it is important to have the necessary knowledge and skills to do so safely. Consider purchasing a voltage tester with additional safety features such as overload protection and high voltage indicators. These features can help protect you from electrical shock and prevent damage to the tester. Regularly calibrate your voltage tester to ensure accuracy. Calibration helps compensate for component aging and environmental factors that can affect readings. Consult the manufacturer's instructions for calibration procedures or seek the services of a qualified calibration laboratory. Stay informed about product recalls and safety alerts related to electrical equipment. Manufacturers often issue recalls when products are found to have defects that could pose a safety hazard. Subscribe to industry newsletters and visit the websites of regulatory agencies to stay up to date. Remember, electrical safety is a shared responsibility. By following safety precautions, using appropriate equipment, and staying informed about potential hazards, you can help prevent electrical accidents and ensure a safe working environment. If unsure about the condition of an electrical tester, immediately discontinue use. A faulty tester may display incorrect readings, leading to hazardous situations when working with live circuits. Promptly replace the tester with a new, reliable model to ensure accurate and safe electrical testing. Voltage testers are indispensable tools for electricians and technicians, but their accuracy is crucial for safety. Faulty testers can mislead users, resulting in potential electric shock or fire hazards. Regularly inspect voltage testers for damage, wear, or corrosion. If any defects are found, replace the tester immediately. Do not attempt to repair damaged testers, as this could compromise their accuracy and safety. Proper maintenance and care of voltage testers are essential for their longevity and reliability. Store testers in a clean, dry environment to prevent corrosion and damage. Avoid exposing testers to extreme temperatures or humidity, as this can affect their accuracy. Clean testers regularly with a soft cloth to remove dirt and debris. Never use harsh chemicals or solvents to clean testers, as this could damage their components. Calibration of voltage testers ensures their accuracy and reliability. Calibration involves comparing the tester's readings to a known standard and adjusting the tester to match the standard. Frequency of calibration depends on the tester's usage and environmental conditions. Consult the manufacturer's instructions for recommended calibration intervals. Seek the services of a qualified calibration laboratory to perform calibration if you lack the necessary equipment or expertise. Different types of voltage testers are available for various applications. Solenoid voltage testers are rugged and reliable, but they can draw significant current from the circuit under test. Electronic voltage testers offer higher impedance and lower current draw, but they may be more susceptible to damage from overvoltage. Digital voltage testers provide numerical readings, making them easy to read and interpret. Choose the appropriate type of voltage tester for your specific application. Voltage testers with continuity testing capabilities can also be used to check for open circuits or short circuits. Continuity testing involves applying a small voltage to the circuit and measuring the resistance. A low resistance reading indicates continuity, while a high resistance reading indicates an open circuit. When using a voltage tester, always follow the manufacturer's instructions. Before testing a circuit, verify that the tester is functioning correctly. Test the tester on a known voltage source to ensure that it provides accurate readings. When testing a circuit, touch the test probes to the appropriate points in the circuit. Ensure that the test probes are making good contact with the circuit conductors. If the tester displays a voltage reading, use caution. The circuit may be energized, and contact with energized conductors can result in electric shock. Always wear appropriate personal protective equipment when working with electrical circuits. Insulated gloves and eye protection can help protect you from electric shock and arc flash. Before working on an electrical circuit, de-energize the circuit whenever possible. Turn off the circuit breaker or remove the fuse that supplies power to the circuit. Verify that the circuit is de-energized using a voltage tester. Even when a circuit is de-energized, there may still be residual voltage present. Use caution when working on de-energized circuits. Never work on electrical circuits when you are tired or distracted. Electrical work requires concentration and focus. If you are not qualified to work on electrical circuits, seek the assistance of a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do so safely. Obtain proper training and certification before performing electrical work. Many organizations offer electrical safety training courses. These courses can teach you about electrical hazards, safety procedures, and the proper use of electrical equipment. Comply with all applicable electrical codes and regulations. Electrical codes and regulations are designed to protect people and property from electrical hazards. The National Electrical Code, or NEC, is a widely adopted electrical code in the United States. The NEC specifies requirements for electrical installations, including wiring methods, overcurrent protection, and grounding. Always follow the NEC when performing electrical work. Proper grounding of electrical systems is essential for safety. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Grounding also helps to reduce the risk of electric shock. Ensure that all electrical equipment is properly grounded. Regularly inspect grounding connections for corrosion or damage. Use ground fault circuit interrupters, or GFCIs, to protect against electric shock. GFCIs are devices that detect small imbalances in current flow and trip the circuit breaker, interrupting the flow of electricity. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Use arc fault circuit interrupters, or RFCIs, to protect against electrical fires. RFCIs are devices that detect arc faults, which are dangerous electrical conditions that can cause fires. A size are required in certain locations, such as bedrooms and living rooms. Use surge protective devices, or SPDs, to protect against voltage surges. Voltage surges are sudden increases in voltage that can damage electrical equipment. SPD diverts surge current away from sensitive equipment, protecting it from damage. Install SPD at the service entrance and at individual equipment locations. Use only approved electrical equipment. Approved electrical equipment has been tested and certified to meet safety standards. Look for the UL or Underwriters Laboratories listing mark on electrical equipment. Do not use counterfeit electrical equipment. Counterfeit electrical equipment may not meet safety standards and can pose a safety hazard. Report any electrical hazards to the appropriate authorities. Electrical hazards can include damaged wiring, exposed conductors, and overloaded circuits. Promptly report any electrical hazards to prevent accidents. By following these electrical safety tips, you can help protect yourself and others from electrical hazards. Always prioritize safety when working with electricity. Remember that electricity can be dangerous, and it is important to take precautions to prevent accidents. The ideal voltage testers that are being recalled pose a significant safety risk. The potential for inaccurate voltage readings can lead to misdiagnosis of electrical problems and potentially fatal electric shock. It is imperative that anyone who owns one of the recalled testers immediately discontinue use and contact Ideal for a replacement. Do not attempt to use the tester until it has been replaced with a new, reliable model. The safety of yourself and others depends on it. The recall of these Ideal voltage testers highlights the importance of product safety and the responsibility of manufacturers to ensure that their products meet safety standards. When products are found to be defective and pose a safety risk, manufacturers have a duty to recall those products and provide remedies to consumers. Consumers also have a responsibility to be aware of product recalls and to take appropriate action when a product they own is recalled. By working together, manufacturers and consumers can help to ensure that products are safe and that potential hazards are addressed promptly.